So our third domain restriction is going to have to do with this one right here that we talked about earlier. And it's a combination of this radical with an even root and this one where you can't divide by 0. This has both of them. And remember we say x has to be greater than 0, but it can't equal 0 because of this rule right here. Now if you look at example 2 again, the numerators, they don't matter because they're not part of the domain restrictions and there's no radical with an even root, okay? On this example, the numerator still doesn't matter, so we're just, as far as domain's concerned, so we're just going to ignore that. For the denominator though, there's a radical and a denominator, okay? So we're going to say that what's inside the radical has to be positive, but in this case we're not going to say it equals 0 because this radical right here is in the denominator. Anytime that happens, the denominator cannot be equal to 0, so just is greater. Now this is just like before. We're going to solve it. We're going to say 2x has to be greater than -3 and x has to be greater than -3/2. So we've solved that linear inequality. We put the values on our number line. Here's our open circle. And since x has to be greater than -3/2, we're going to shade this way to the right. And now we're going to use a parenthesis instead of a bracket to indicate that it cannot equal that value. And this would be our answer in interval notation. So just remember those 3 rules, and the last one that we're going to do now is a combination of all of this.